And okay, we've done the first overview of what is this all about. And Hylke will now be starting with the second block on how to really do the deployment of a SensorThings instance. So Hylke, it's on to you.
Yes, let me share my screen. You're still sharing. Now I can share. Okay, does that work? Should be working. Right, so I'll be doing a tutorial on deploying a SensorThings API server, adding some data. Then we'll be going into how do you query a SensorThings API service. And at the end, we'll be making a little map to show data from a SensorThings service in a visual way. I don't have PowerPoint slides. Instead, I have this website so that everybody can nicely follow it later. I will post the, where's the chat? The chat got hidden. More chat, there's the chat. I will post a link in the chat. Did that work?
That came through the chat.
Good. Okay. And is everything readable with my camera still on, or should I just turn my camera off?
The camera comes in a different window, so one still has the full screen. You might want to make it one strict plus larger. Okay.
So deployment. In the API for Inspire project, we're using the Frost server as a SensorThings API server because that's the one we developed, and makes much sense to use that one. And for start, I'll quickly show how can one deploy such a server. Basically, there are two main ways to deploy Frost server, either using Docker, or if you already have a Tomcat server running, and you can add a Frost server directly to your running Tomcat. For this tutorial, if you don't have Docker and are also not a Tomcat expert, that's also not a problem, because we have a publicly available SensorThings API instance that everybody can read, write, and delete everything on. I will also post this URL in the chat. So if you want to follow the examples, you can try out there. And there everybody can follow the tutorial as well. So deploying Frost in Docker. Using Docker is usually the easiest way nowadays to quickly get a server running. And Frost is following that trend and is also made available through Docker. And one of the tools that comes with Docker is Docker Compose. And Docker Compose allows one to quickly get several parts of a server that belong together, all running at the same time. So you don't have to separately install a database, configure a database, and then install maybe an MQTT server and configure that, and then install Frost and configure that. You can use Docker Compose to configure that in one go. So for that you have a Docker Compose YAML file. On the website there is this link to the Docker Compose YAML file. If you open that in the text editor, you can see it has let me open this version. So it has a couple of blocks. This is the definition of the Frost web service and MQTT part. It has some configuration options like and the second part is the database, because Frost needs a database, of course, to store its data in. And the database then uses a persistent volume so that if you restart the server, not all the data is gone. So to start this server, on Windows it's probably a little bit different, but if you have Docker, you should probably know how to do this. It's a matter of saying Docker compose up. If I make this a bit bigger, there's a lot of text coming by now because it's a fresh server. So Docker has to, Frost has to do some initialization, create its tables, and then it is now done starting. So now if I go to my browser and say, okay, localhost 8080 Frost server, there I have my Frost server instance. So easy can it be to start a SensorThings API server? Of course, this example was for Frost, but I do know that, for instance, Ghost has basically the same Docker Compose feature, because yeah, it makes no sense not to support Docker. But as I said, if you can't try it out now with Docker Compose on your, or Docker on your own machine, you can go to the OGC demo URL on our demo server and create entities on that. So now we have our server. We go to the 1.1 endpoint, and there we've got our server list or our entity list. And of course, if I go to things by clicking on the things link, there's nothing there because it's a fresh new server. It's still empty. So the first thing, creating entities, how do we do that? Well, as Kathi already mentioned, creating entities is done by posting the entity to the, so creating a thing is done by posting the thing to this v1.1 or v1.1/things URL. I make a post to my URL/things. So how do I do that? Well, posting is one of the standard features that any browser can do. And but since posting is usually a little bit hidden, I mean, to make a get, you just type it into the URL bar, but posting is usually a bit hidden. The Frost server nowadays has this little form right on the landing page. So also if I go to the OGC demo instance, right here we've got a little landing page, with a little tool that allows one to post an entity. So let's try that on our server. Of course, if you post an entity to a public server, you should put your nickname or something in there that you can actually recognize that it was your entity. So let's say it's Hylke's Kitchen. Leave the thing itself, the rest the same. We want to make a post. Where do we want to make a post? We want to make a post to the collection of things. So v1.1/things. And then we just click execute, and then it says done. And the thing that comes back is the URL of the thing that was just created. So here you can also see in this browser, this is the base URL of my server, Frost server. Let's see, you can also see that in the top in the URL bar, 8080/Frost server. And then version 1.1, that's the version number we were using, and then /things, we were posting to /things and 1. Because this is the very first thing that is being created in the server, it gets the first ID, which is 1. So if I now go to my URL, go to the version 1.1 endpoint, I have here my list of entities, and then in things, there is now a thing that I just created. Now let's quickly look at the other page, if anybody else did it. Yes, we've got lots of things. People have been clicking. And some people have been nicely putting their name in it. Here also one. This person only has a kitchen as a house. So very good. That's how easy it is to create an entity in the SensorThings API service. Exactly. So what you get back after post is the location in a header, the location of where you just posted, where this thing was created. Of course, there are more entity types in the SensorThings API server than just things, and of course, the thing, and at the end, we're interested in making observations, but you cannot just start making observations. You have to create some of the other entities as well first. So there's a certain order in which you usually create the entity types in the server to get your server configured for accepting observations. So usually you start with a thing and a location. Sometimes you first do the location and then the thing. Next comes the observed property, whereby observed property is a bit special because usually for each type of observed property, you only have one in your server. So you can have lots of things that all measure temperature. And then you can have thousands of things, but only one temperature observed property, because that one is shared between across all the temperature observations. Sensor is also a little bit special in that usually the sensor describes the type of sensor. So if you have 1,000 sensors that are all exactly the same type, and there is nothing really to distinguish the types of these sensors, you can also get away with just one instance of that type of sensor. And there you can then have the relevant information that describes the sensor. But in some cases, you do have relevant information for each individual sensor, like when it was calibrated, or exactly how it is mounted, or some things like that. And then you can actually also make an individual sensor entity for each physical sensor. And then you also have lots of sensors. Next then is usually the data stream. So for one thing, one sensor and one observed property, you can make a data stream. And in the data stream, you then have observations. That has not yet, then you have not yet made a feature of interest. And that's okay, because as long as your thing has a location, if you then post an observation without saying what the feature of interest is, the server will generate a feature of interest from the location of the thing. Because in many cases, your thing is not moving, and you can't really make a sensible feature of interest that's really different from the location of the thing. So that makes it a little bit easier. You don't have to separately create feature of interest, and then when you create an observation, you have to specify, oh, that's feature of interest. You can leave all that out, and the server will generate one for you. So next up is creating a location. And of course, this location, we have already created a thing, and hopefully you all remember the ID of the thing you created. If not, you can fortunately easily look it up. And now we want to create a location and link that to the thing we just created. So to create a location, we post the definition of our location to the /locations endpoint. So a location also has a name, a description. A location also has an encoding type, which describes how the geometry is described of your location. Usually that's GeoJSON, but in theory you could also have text there and have a location that is a description, like an address, or 5 meters north from the big tree and then 3 steps to the left, which is technically a valid location. And then your encoding type would of course not be application GeoJSON, but application text or application pirate description. And lastly, a location can have many things. So if we want to create a new location and directly link it to our existing thing, we have this array of things here with one entity in it, and that entity has an ID, and that ID is then the ID of our thing we just created. So let's do that. Let's copy this to our posting tool. So the ID I just created, or the thing I just created, was 1 in my case. So I get at IoT ID 1 for my thing. And of course, I don't want to post this to /things. I have to post this to /locations, but it is still a post. So I then execute. And it's done. I now have version 1.1 /locations, also location 1, because this was the first location. So I can now look in my server to locations. There it is. And there I have my location. And one of the really nice things of the SensorThings API and OData in general is that it directly shows in the default representation of your entities all the links that those entities have. So this location has a link to itself. That's the self link, which is again the basically where to find this entity. But it also has a link to things. So if I click this link, it goes to /locations1/things. I get all the things that are at this location. If I click there, I get indeed the kitchen in my house. And this thing again has a link back to locations. If I click this one, I get the location of this thing, which is indeed, this is where my kitchen is. Things can move and then they get new locations. So whenever you link a location or a location to a thing, a historic location is also generated. And here we see this historic location was made at this time. This is when I posted this location. By default, it gives UTC, so universal time. And that's currently an hour difference. So right now it's here 15:57, and I made this 1 minute ago. And this historic location again links to both my thing and my location. Oh. So let's see if other people have been making locations. No, I don't want to do this here. I wanted to go here. That one, exactly. Locations. Well, yes, 2 people have managed to make a location. So next up, I want to create a sensor and an observed property. First, observed property. Well, I made a kitchen, and in this kitchen, I want to measure the temperature. So let's make a temperature observed property. So I go back to my start page, replace this this JSON, and say I want to post to observed properties. And that's also one way you have to be careful. Of course, the multiple of observed property, and one observed property is an observed property with a Y. Of course, you don't multiply that by adding an S. You actually have to make an observed properties. That's also one that can trip you up. You don't just add an S in English to observed property. Again, a post to this. It's a temperature, and this is the official European Environmental Agency definition of temperature. For fun, we can have a quick look at that. It's the vocabulary that describes temperature in the meteorological sense. So that's a clear reference to a definition of temperature that could be used in many use cases. So let's execute that, and that worked. So now I have observed property 1. And of course, in my case, I'm in luck because they're all getting ID 1 because it's a fresh server. Of course, on the other server, they will be getting different IDs. And then the last one is a sensor. /sensors. So a DHT, oh, that's a typo actually. DHT22 is a typical standard sensor used a lot in hobby electronics. It's pretty cheap. These things cost about €5 if you buy them single. If you buy them in bulk, you can get them a lot even cheaper than that. And you can easily build those into your house if you're so inclined. I actually have a few of those in my house. And so post that to sensors, execute, and now I've got a sensor. So now we go to a data stream. So let's say we want to measure the temperature in our kitchen. So for the data stream, a data stream must have a thing, a sensor, and an observed property. You cannot have a data stream that does not have all three of those. So when we create a data stream, we must specify the thing. And since this is only a data stream can only have one thing and must always have exactly one thing, that's not an array, but just directly an object with an ID. And same with sensor and same with observed property. We copy our example text. / data streams. Oh. So it has a bit of extra thing. It has a name, so you can recognize it. Usually I like to put both the observed property name and the thing name sort of in there, because then you can actually find it back. In many cases, people name it just temperature, but then if you have 1,000 things that all measure temperature, you end up with lots of data streams with the name temperature, and then you can't really distinguish them from there anymore. The observation type is a reference to the actual OGC definitions of OGC observation types from the O&M 2 standard. The unit of measurements is in the data stream. So that means that all observations in a data stream must use the same unit. Which is actually something that tripped me up when I was importing data from the EEA, because there one of our users suddenly sent me an email and asked why this one data stream had suddenly had values that were 1,000 times as large, and that was because the CSV files that the EEA supplies do not follow this principle, and there they halfway suddenly changed to unit, and I suddenly had values that were 10 times as large. So I had to update my importer from the EEA again, that it actually double checked for every individual observation whether the unit was actually correct, and if not, it had to calculate the correct unit. So the IDs, I was in luck, they were all for me all one. Of course, if you just created one entities, and you can look them up. So let's see if anybody created the sensor. Sensors. Yeah, 2 people have created the sensor. Of course, in this case, because they're the same, these 2 people could have used the same sensor, but it's okay. Observed properties, and indeed they also created observed properties. They made a little difference there. Somebody edited it a bit. That's good. So that should be all we need for our data stream. So let's execute. Yeah, and now I have a data stream. So let's double check. Let's go to server 1.1/data streams. And indeed, there we have my data stream, and then links to all the sensor and the observed property and the thing there. You see an extra entity here. Result time is null. Data stream has a few properties that are auto-generated by the server. So there's result time. There's also a phenomenon time. And the phenomenon time of the data stream is the interval for all the observations in that data stream. So that's automatically generated. But we'll see that once I add an observation. So we've got our thing. Let's go back to the data model for a bit. We've got our thing that has a location. We've got our sensor, our observed property, and our data stream. So now we should be able to add an observation. Let's do that. Back to observations. So for observation, when creating observations, there are a few extra rules, or actually they make things easier instead of harder in this case. When you post an observation and you do not specify the phenomenon time, then the server will just take the current time as the phenomenon time. So if you have a sensor that doesn't have a clock in it, you can just post your observation and the server will take the time, add the time to it. If the same goes for the feature of interest, if there is no feature of interest, the server will try to generate a feature of interest from the location of the thing. If it can, of course, if you have a pirate map that has a description like third tree to the left and then 100 meters to the north, then it won't know how to generate an observed property or a feature of interest from that. And if the result time is not given, the value null is automatically used. So the minimum thing we have to have for an observation is a result and a data stream. So let's try that. Copy that to our start page. Replace our JSON. Well, I was lucky again. My data stream was 1. And post that to /observations. Observation 1 has been created. Let's check that. In our data stream, we can just go to the observations of the data stream by following this link. And indeed, there is our 1 observation. Now we can shorten this JSON even more, because there are 2 ways to specify a relation when you create an entity. You can put it in the JSON like this, so you can post to the collection of all observations and then say, this observation I want to make is for this specific data stream. Or you can post to the collection of observations for a certain data stream. So if I post to data streams and then in quotes 999/observations, I will be creating a new observation for data stream 999. So let's also try that. Go back to our thing. Let's remove this bit of data stream and also this comma and change the result so we know we actually made a new one. And now let's do that to data streams 1/observations. Execute. And indeed we have observation 2. So if I reload this list of all the observations of data stream 1, we should now get indeed 2 observations. So that's very short, the absolute minimum you have to do to get observations into a SensorThings server. Are there any questions so far before we go into importing many observations at once? I usually do these tutorials live, and then the communication with the participants is a bit easier.
Short comment, there are no stupid questions. They are just bad explanations from our side. So
yes,
something is not understood. It's not that you haven't understood it, it's that we have said it wrong.
Or we have not yet gotten there, and then it's a very intelligent question because it's something we will cover later.
Okay, so either your explanation was really good, or they've all gone off for coffee and have just left their webinar running.
Well,
I hope it's the first.
Let's test and let's see if we have observations in our demo server.
I've only seen your data stream.
Yes, we've got 3 observations in our demo server.
And there's a second data stream. Okay, people are playing. Very good. This was the goal. And I mean, it is tricky with all of these bits. It takes a while to get your brain around, and the best way to get your brain around it is to play with it.
Exactly.
And that's why we've made all of these nice toys that you can either just play with the nice Virgin Frost server there and trash it as you like. And if you want to get a better overview of the data, that's also what all the endpoints are there for. Can also sort of give you a lead on how to structure different types of data, because there are vastly different data sources being provided, and for each one, Hylke and I would do a bit of headbang. How do we structure this one best?
Yeah, exactly. This use case of a temperature sensor in your kitchen is the easiest. That's why I'm using it here. But we will get to more complex examples in our getting data and our mapping examples. So next one. Of course, in many cases, you might already have a bunch of data. And then you would like to be able to import that data from, for instance, a CSV file. And that can also be surprisingly easy. So I made a little script here. That's actually a web page that's linked here, which is an observation importer. It already comes with some demo data. So I give the URL, which, because this runs in your own browser, it can actually be localhost. So the thing you run on localhost, but you can also add the change this URL to the OGC or the OGC demo endpoint. I just need to say what the data stream ID is here, datastream1/observations, and I want to post these data. So this very simple importer, I'll explain the workings a bit later, takes a CSV file with 2 columns, a time in official ISO format, and a value, and this one just goes from 1 to 10, and then again from 1 to 10, and again from 1 to 4 for today. So I'll be posting future times, yay. And then you click execute, and hopefully that works. Something went wrong. Of course, I have browser plugins that block things. Let's try that again. Now it works. So it made observation 3. That's of course correct because the previous one was 1. Because it just posts all of these observations in one go, they get back in a bit of a random order. Here's 4. But it did make up to 26 is I think the highest number, which would be correct because 24 hours plus the 2 I had already made manually. That seems correct. So let's go back to our data stream and reload it. And yes, indeed, now I have a lot of observations. Of course, if I click again, it'll just, If I click again, it'll just post the same observations again with the same times, and then you do have duplicate times. So, but let's go over how this is made. Of course, since it's a website, you just can right-click and view page source. And you see it's not even a very big website. I'll get to the JavaScript later. I'll start with the little form. So we've got a little form that has a label for my URL. That label is just URL. And then an input field of type text for the URL with the default value of this. And there's an input type of a button. That's the execute button. And when I click that, it executes some JavaScript. And then there is a text area, and that's where the JSON or the CSV goes. And then at the bottom, I've got a little element that for displaying the errors or the success text. So let's go to this execute bit. Here's the function execute in JavaScript that reads from the document the URL that I want to post to, and it reads the data. And then it fetches that little bit at the end where I wanted to have the results displayed, and it replaces the contents of that bit with a little bit of text importing data. And then it passes on to the next function, process data, passes the URL and the data to it. This process data just takes the data and then splits it on line endings. So this is just a fancy way to get individual lines. So then I have an array of lines. And for each of these lines, it's an array, so I loop over the array from 0 to the length of the array. Each of these lines, I take the current line and I split it on a comma, because it's a comma separated line, it should have a comma. Of course, this is very naive, because if you have a value that has a comma in it, it will get confused. And it checks whether indeed there are only 2 values, not 3 or more, or less than 2. And it makes an observation. It puts the phenomenon time as the first field of data it found, and the result is the second field of data it found. And it trims it so it removes any byte spaces from both sides. And then it hands off to the next function, post, with the URL and the JSON of this observation I just made. And what does this do? It creates an XML HTTP request, which is a standard browser function. It adds a listener for when it's a success. It adds a listener for when there's an error. It opens this with a type post, because I want to make a post, not a get or a patch or something, to the URL. I set my header of content type to application JSON because I have to post JSON, and then I send the data. And because this function post is being called for each of these lines that it found in the data, it just goes over everything and posts it all to the server. So that's a very simple, very naive importer. Again, in the in the website, there's the same explanation, just a little bit more color. And of course, this is a very naive importer. Like I said, if you click execute again, it'll just resend the same data. And then you get duplicate values. So if you would want to make this more advanced, you could first check if there is already an observation for this exact phenomenon time and this exact data stream, and then you know, okay, I don't need to re-import this one. Or maybe you want to go even more advanced and check, okay, there is already one for this value, for this phenomenon time, but it might have a different value, and maybe I then want to update the value. That's all things you can do. And of course, this simple importer only imports observations, and it doesn't actually create new data streams or whatever. And it also doesn't create observed properties and things. So if you have a big import from an external service or so, you usually need a bit more than just a simple HTML page. So that's so far importing. Then next up is updating and deleting. Because like I just mentioned, like I just said, maybe you want to update your observations or your things. So updating is done by sending an HTTP patch to the self link of an entity. So let's have a look at that. That one can go away. That one can go away. So we've got here our HTTP tool, and we've got our data. So let's go to /things. We've got the kitchen in my house. The self link is here, so let's copy that. Copy link and paste that in my text here. And let's say I want to change the description. So I want to patch, not post, and I want to change the description to be it's red, because I like red. Execute. You don't really get an, if everything went well, you don't really get a result from that. Do I now reload my description? Yes, my kitchen is now red. Actually, I don't really like the red, especially not in kitchens. Blue is better for kitchens. There we go. Now it's blue. You can also, for instance, for a data stream, link it to a different entity. Let's try that. Let's create a second thing. For that, I'm just going to reload this page. Oh, there we go. We've got to make a new thing. That's my second kitchen, because I've got a huge house with multiple kitchens. So now I've got thing 2. And now I go to my data streams of kitchen 1. Data streams. I get the self link. Location. And now I want to link this data stream to another kitchen. Usually you don't really do this, but well, you might have to, you never know. So what do we want to do for that? Well, we want to post something. No, we don't want to post, we want to patch our data stream, and we want the thing to no longer to have different ID. So add iot.id, and I want to link it to thing 2. Let's hope this works. Seems to work. So my data stream has a thing, and if I now follow this link of data stream 1/thing, it should now be indeed thing 2. And if I go to thing 1, go to things, I've got my 2 kitchens, thing 1, and data streams. That one no longer has a data stream. So that's how you can also relink entities. You usually do that from the side of the link that has the singular item. So a data stream, if I quickly go back to our data model, a data stream has only one thing. And so usually you would change the link from the data stream side. So then you post the data stream with the thing ID. Same with observation, has only one data stream, and the data stream only has one observed property and one sensor. You can also change the location of a thing, and then you usually do that from the thing side. And that's where things work a bit different, because then also a new historical location is created, because you moved your thing to a new location. So back to memory, updating and deleting. Exactly, deleting entities. You can also delete entities. That's done by very predictably sending a delete command to the self link of the entity. So if we go to our thing, thing 1 is now no longer has a data stream. Thing 2 does. So let's go to thing 1 and copy the self link of that. Post it in here. And then we say delete. With the delete, it doesn't matter if you put anything in the box, you can leave it out because it's ignored. So delete thing 1, execute. Doesn't really say anything, but my thing is now gone. So if I ask for thing 1, I get an error 404, nothing found. If I go to the collection of things, there is indeed only thing 2. Deleting things, you have to be careful because all entities that depend on whatever you just deleted also get deleted. So again, if we go back to our data model, a data stream must have a thing. So if I delete a thing that has data streams, the data streams also get deleted. And an observation must have a data stream. So if the data stream gets deleted, the observations also get deleted. So if you want to delete lots of things in entities in a server, you usually just delete things, and that automatically deletes the data streams and observations as well. It won't delete observed properties or sensors or features of interest because they can exist without any other entities. Historical locations also must have a thing, so historical locations also get deleted when you delete the thing. But locations do not, because a location can exist without a thing. You can also have multiple things at the same location. So that's as far as updating and deleting entities goes. Any questions so far? Do we still know that people can delete? Do we still have any entities in our demo server? We do. Nobody has deleted everything yet. That's nice. Yeah, we do have lots of updated kitchens as well. Cool. Let me check the chat if there are any questions. It seems there are. Oh, where is the chat? Chat.
That is fairly quiet. I've been monitoring that. So, I mean, the URL structure is totally specified by the SensorThings standard, the tricks with putting the ID in the round braces at the end. This is the one major difference to OGC API.
Yeah.
We have a different way of referencing individuals as well as a different and more complex query logic. A short question to Mark is, does it answer your question?
And indeed, this header is also documented. We can actually just, I've not even done that yet. OGC SensorThings part 1. Let's just go to the standard. Part 1 sensing of version 1.0. And that should have.
Can you pull your chat box out? Because that's blocking part of the screen.
Oops, sorry. Location, lots of location. No, that is not what I was looking for. Creating entities. So this is the standard is actually.
No, there's no undo. If you delete something, it's deleted. You've got to remember what you had and put it back in there quickly.
Yeah, if you start deleting things, better make backups first. There is no hand holding. Although I suppose technically a server could implement something like a wastebasket and try to store everything there, but that becomes very inefficient when you delete a thing with a million of observations, because then it would have to do tricky bits and.
I mean, note to all: if you're developing an application, you might want to foresee this before you do a delete. You can first query the thing, store it locally, and if the user realizes that delete was the wrong delete, you just post that bit back in. Tricky is the cascading bits.
Usually, most users also do not have the rights to delete things. Most servers will have some form of security, either built into the server or in the reverse proxy that the server is behind. And because those HTTP verbs are a really nice way of specifying the delete, you can just block all deletes, for instance, at the reverse proxy level, and then you cannot accidentally delete something. That location header, here it is. Upon successful completion, the response shall contain an HTTP location header that contains the self link of the created entity. So that's actually in the official standard where that is documented. Yeah, but it's indeed a bit hidden because it's only one sentence, and it's something a lot of users miss the first time they work with the standard. That's why I explicitly mentioned it in this tutorial.
That's the difference between a tutorial and a standard.
Yeah. There are lots of little lines that you miss in the standard the first time you read it, and you notice them later. But that's also why there are no stupid questions, because this standard is, when you really want to know everything you can do with it, it's a lot. But the simple things are actually surprisingly simple. So next up in our tutorial is a bit of an example entities. If you want to create entities, here is examples of all the entities. So you can just copy paste and get going quickly. And then there's advanced entity creation, because of course creating all those things separately can be quite a chore, and you have got lots of posts going. And for instance, if you have 1,000 stations and every station is at a different location, you'd have to make 2,000 posts to get first all the stations in and then all the locations in. And to solve that a bit, you can actually create related entities in one single post. So here we've got a really big post. It's a thing. It's supposed to be posted to /things, and it creates a thing. It also has a location, but instead of just having the ID of the location here, it has the entire location entity embedded in it. And what will happen if you post this, the server will directly also create this location and link it to this thing. And then here we also have a data stream, or multiple data streams actually, that has the data stream. It uses an existing sensor with ID 5, and it creates a new observed property. So you can mix and match existing ones and newly created ones. And it also has a second data stream, humidity, and it's again the same sensor, but it also creates an observed property. So that can help in reducing the number of posts you have to make when you're initializing a server. And on the Frost website, I actually have a demo post that also has observations in it, and so using that, you can have a server with all entities pre-configured in one post. Of course, when you do post this, the header, location header that comes back only has the ID of the thing, the top level entity. But since the others are all linked from that thing, you can find those as well. One of the funny things with those coordinates, you often see people posting things, coordinates with 15 decimal points. I think that's a precision on subatomic level. Usually 6 decimal numbers is plenty for your GeoJSON. But that concludes how to deploy and get running a Frost server. Are there any burning questions about all of this? And of course, you can reread this at your own leisure at the API for Inspire website. There's another question in the chat.
Further questions? Otherwise, you're going to be stuck doing the next survey bit before Hylke shows you the really cool stuff.
We've got a survey bit now. Good. Shall I stop sharing then, Kathi?
You stop sharing. I will try and take that over again.
And I will also turn off my video for a bit, since you're now on.
Okay, next round of survey, please. So how much do you like what you've seen? To what extent could this make your life happier, more productive? Okay, this is looking positive. We haven't confused people too badly. I mean, I'm the first to admit that the details of some of this stuff can get pretty scary.
How many people? Oh, we can still have 31 participants. That's good.
We haven't scared everybody away yet. Okay, based on the audience size and the fact that it's slowing down, I think those who will answer have answered. But I would say the overwhelming majority thinks this is a sensible way to go. I'm glad that nobody said not useful.
Yes.
The okays I can live with, 1 or 2 mostly works I would have also dealt with. Nice. Next question. What relevant metadata are you missing?
We didn't go too much into detail on the metadata yet.
Where I made a short background for everybody who's trying to figure out what we mean by metadata here. The problem is that term is seriously overloaded. The question is, are we dealing with discovery metadata the way it's usually referred to in Inspire? In our focus, a lot of what we consider metadata is more the measurement meta information. What we are missing are links back to an Inspire compliant catalog service. That is something we may also want to foresee in future Frost versions. Or Hylke, would that be possible to add a link to somewhere at the bottom?
Yes, you could add a link, for instance, in the index page, because since version 1.1, you can add extra things to the index page. Well, for instance, the observed property can have a definition link to an external service. I actually showed them that one, linking to the EEA. And of course, in your things, in your properties, you can put any metadata you would like to put there.
Giacomo, thank you. It's true. The question is also not clear. I'm realizing now I don't quite know what yes and no means. So I'm still going to take this as a pointer to the fact that we need some more backlinks to the relevant metadata and do our best guess what our audience was really trying to tell us. Thank you very much for pointing out my confusion to me. Okay, going on to something, let's see if this is more fitting. So I mean, assuming some use case from your real world life or also what you would like to do, would SensorThings really fit for that?
Yes, and if it doesn't, we are really interested in hearing that because, of course, now that version 1.1 is almost finished and approved, and we will, of course, be starting version 2. And if there are use cases that are not working, we'd like to know because we might be able to fix that in version 2 then.
Exactly. Please tell us, and also those of you not involved in the OGC, it's even more important that you tell us since you won't show up at our meetings. But if you get the information to me or Hylke, we will do our best to make sure that this is integrated and shows up if it's possible. Okay, but I think we actually are providing a technology which is something people are looking for. So whoever said no, please provide us more detailed information. You can provide it in the chat. You can send it as an email to us.
You may also post it in the GitHub or either the API for Inspire GitHub or the SensorThings API Standards Working Group GitHub. It's also public.
Okay, I'm going to assume that the majority of the audience is happy and the one unhappy person will hopefully explain to us how we can make them also happy. How are you dealing with the overhead? I mean, we know it's a bit trickier than a lot of APIs, but at the same time, the benefit is worth the trickiness from what we have seen. Again, we'd like some wider feedback on that because we are so involved in this technology. Of course, it makes sense to us. I mean, we were among the people defining it. Hey, you didn't scare them too badly. Cool.
Yes. And we haven't even gotten to the real details, nitty-gritty details of filtering and expanding and things like that.
Okay, maybe you can scare them the second part.
But you can all ignore that. You don't have to use it.
Okay, any more questions? Okay, now we're done with the questions until after Hylke has done his best to really confuse you.